Okay, awesome. Let's make a start then. So, good morning, everyone. Today I'm here to talk to you about how you can build event-driven systems on AWS using native service integrations. And what I mean by native service integrations is that we're going to build an application on AWS without a single line of code running in the production system. We are going lambda-less, as the title says. So first, just a quick show of hands. Who considers themselves a developer or has written code at some point in their career? Yes, this is the builder track, of course. Keep your hand up if you've ever deployed a piece of code that has broken something in production. I'm going to put 2 hands up, because I've done that many times. Of course, I'm sure we can all agree that code is a little bit of a liability. Every time you make a change to a piece of code, you introduce that risk of breaking something, introducing an issue in production. Code that doesn't change is, of course, the most stable kind of code. Until, of course, in a year's time when you need to add a new feature to that code and nobody actually knows how it works anymore. Serverless started to abstract away a certain type of issue, issues around the underlying hardware or around operating some of these systems. And that's awesome, because now with serverless, we can start to focus on the things that matter as developers. We can focus on our business logic, on adding value to the people using our systems. And some more advances in technology have allowed us to write even less code. Things like translation, video transcription, text-to-speech, all these things are now just an API call away in AWS. So when we're consuming these APIs, this is code that obviously needs to be maintained, it needs to be managed, packages that need to be kept up to date for what is, in essence, just a few lines of code that are just making an API call. So what we're going to look at today is how we can start to reduce the amount of code we write even more. This code that's doing undifferentiated heavy lifting, code that's just making an API call. How we can remove that to allow us as developers to focus on the things that matter. Focus on solving the hard problems that made us want to be developers in the first place. So who am I? I'm James Eastham. I'm a professional services consultant at AWS. So by day, I'm working with AWS customers to help them build things on AWS. By night, however, I am a passionate .NET developer. So there are some code samples in this talk. Apologies for any TypeScript, Python people in the building. They're all in .NET, unfortunately. And serverless and event-driven architectures, they are my big areas of interest. So to start with, given that this is the builder track, let's have a look at what we're actually going to build. And to do that, I want to set up a problem statement for you all. So imagine in whatever the system or whatever the applications are you work on today that you need to add a new feature. And what that feature is going to allow you to do is to collect reviews for whatever it is your system is. It needs to collect them reviews in any language. It needs to translate them reviews to English. And it needs to perform sentiment analysis on them reviews to work out if they're positive or negative, if somebody loves what you're doing or doesn't. If they're negative reviews, we want to then store them in a queue of some kind for a human to actually take up and look at and work through. If they're positive reviews, we want to just send an email back to the reviewer to say thank you for your kind words. So think about how you'd go about adding that in your current application today. How would you start to build that? How we're going to build it in this session, and all the code for this is on GitHub. I do normally have a few demos in this talk. I don't have time today, but if you are interested in seeing this running, then come and grab me afterwards. But what we're going to build is 5 completely independent services that are not loosely coupled. They communicate entirely through events. And as I said at the start, this is an application that runs without a single line of code running in production. This is all native service integrations. So what have we got here? We've got a front-end service that's going to allow us to receive requests in, so an API. We've got a service to perform the sentiment analysis to actually do this translation and actually work out if they're a positive or a negative review. We've got an audit log just to keep a track of all the events that are flowing around our system. We've got our customer service workflow that's actually going to store up these negative reviews for a human to look at. And then finally, we've got a service to send notifications back to the reviewers. So this is what we're going to step through and build throughout the rest of this session. But first, I'm seeing a few concerned faces out there, because I've said it a few times now. We're going to write an application without a single line of application code. So is this me now telling you that we're all about to be out of jobs as developers, and this is where the robots truly come and take over? Absolutely not. So what low-code, no-code solutions allow us to do as developers is to focus on the things that matter. Focus on writing the code that's truly going to make a difference to our customers, not the undifferentiated heavy lifting that comes with operating packages that just make API calls. We can really start to focus in on adding value to our customers. And that's great. I can say we can focus in, but then how do we start to identify the parts of our system that we want to focus in on? And to do that, I want to really quickly just talk about domain-driven design. So for anyone who's not familiar with domain-driven design, it was a book published in the early 2000s by a guy called Eric Evans. It's a huge, chunky book. There's quite a lot of different concepts in it, but the concept I want to talk about today is this idea of subdomains. So in every domain, there will be a set of subdomains, and there's 3 different types of subdomains. There's your core domain, there's your supporting subdomains, and there's your generic subdomains. Okay? Your core domain is where you want to focus as much of your effort as possible. This is your USP, the thing that's really adding value to your customers. You've got your supporting subdomain, and your supporting subdomain are parts of your systems that are required for your system to work, but aren't differentiating. So in the example we set up at the start, things like translating from Spanish to English. That's something that anybody can do with an API call. And then you've got generic subdomains, and generic subdomains are the completely undifferentiated things like sending emails, for example, things that all customers need to do. Now, as developers, we want to be focusing as much time here as possible. As much as possible, we want to try to move away these supporting subdomains and generic subdomains, things that aren't adding value to what we're building, and focus on this core domain. So no, we're not about to all get run out of a job by the robots. Okay, so we've identified these separate domains in our systems now. So how do these domains start to talk to each other? And I've kind of given this away in the title a little bit with the whole event-driven part of it. But when you're trying to communicate between different parts of your system, coupling becomes one of the most challenging things that you need to solve. So how do you determine how you're going to couple these parts of your application together? I really like this quote from Gregor Hope when you start to think about coupling. The appropriate level of coupling depends on the level of control you have over the endpoints. And what I mean by that is that if you say you're a team that owns maybe 5 services, you develop 5 services, coupling them services together may not be so much of an issue, because you control the release cycles, you control the SLAs, the schemas, etc. But if you're starting to work with a system that you don't control, maybe another system within your organization, maybe a third party, you want to try and reduce that direct coupling as much as possible, because you don't have that control over their schemas, their release cycles, their SLAs. Even outside of the application level, if we start to think about the fallacies of distributed computing, these are false assumptions that people new to distributed systems make. And when you're building things on AWS and in the cloud, almost every system now is a distributed system. I've highlighted some of the network-related fallacies in bold there, because these are things we have even less control over. The network may go offline. The network adds latency to our systems. These are all things that we need to think about when we're trying to build systems that talk to each other in some way, but still provide a really good experience to our customers. So I've just set up a bunch of problems there. So how do we actually start to solve some of these problems? How do we solve some of these problems of communication? Well, that's where we can start thinking more asynchronously when we think about our systems. So typically, when applications communicate with each other, you may have one service where a request comes in that talks to another service, and then another service, and another service down a chain. And if these are all synchronous communication, these are all blocking calls, if any one of them services goes offline, that's going to cascade back through the chain, back through the rest of your system. If we start thinking more asynchronously, we remove that blocking nature, that risk of cascading failure. So we can simply publish an event from one system, and other systems can then choose to react to that event if they want to or if they don't. So instead of it being more of, I ask a service and it replies instantly, it's more, I ask a service for something and at some point later it will respond. So event-driven architecture becomes a really powerful way to build systems while still dealing with them realities of distributed computing. Okay, I realise this is a builder session and I've talked a lot about more theory-based stuff now, so let's actually get into the how. How can we actually build systems on AWS that start to deal with some of these challenges? And in the architecture I flashed up earlier, there's two key services that make all of this work. The first of which is AWS Step Functions. So a quick show of hands, who's heard of or used Step Functions before? Awesome, that's what I like to see. Okay, who's only ever written a step function using the JSON or the YAML syntax? You know, handwritten, that JSON or YAML. Okay, awesome, a few hands. Okay, you're in for a treat if you just put your hands up in a few slides. So Step Functions at its core is just a workflow engine, as many of you already know if you're already using it. With Step Functions, you can define a set of steps, and you can pass state from step to step to step. Along the way, you might manipulate that state, you might use that state to perform some action or some task. When you invoke a step function, you can pass in an element, a payload into your step function that you can then use as part of the workflow. Step Functions is really powerful because it allows you to build these reusable components. So if your business requirements change, or maybe you need to add a new feature, you can do that with this set of reusable building blocks that you can use to develop as your business needs change. Step Functions also integrates with a wide range of different AWS services. We'll get onto that in a little moment. So as I said, under the hood, Step Functions is built in what's called Amazon States Language, or ASL. ASL can be written in either JSON or YAML, and at least personally, when I first came to Step Functions, started to try and understand ASL, it was a little challenging, shall we say. It is an interesting syntax to start to get your head around. And at that point, I kind of stepped away from Step Functions for a little while. I stopped using it. That was until last year, where the Step Functions team released the Workflow Studio. Now, for anyone who hasn't heard of Workflow Studio or seen Workflow Studio is a drag and drop interface that you can use to build and design your workflows. So you get a big long list of all the reusable components that you can use in your workflows. You can drag them in and build your workflow visually. There's two reasons why this gets really powerful. The first is that you can actually export the ASL from this interface. So you can export that JSON syntax, put that into your version control, your CI/CD pipelines, and deploy that with good DevOps practices. You can also import ASL back into Workflow Studio, and that's commonly how I build step functions. Build it in the Visual Designer, export it, do some stuff, import it back in again if I need to make some changes. The second reason it's really powerful is it allows you to get a lot closer to the business people who are defining the requirements of the things you're building. So business people don't need to understand what a Lambda function is or what SNS is, but they can sit and look at a visual diagram, what is in essence a flow diagram, and really start to understand how things are flowing through your system. And that is a really efficient way to start to develop features because you're developing literally sat next to a business person. The third way you can build step functions is with the Cloud Development Kit, or the CDK, and that is what this entire system is built on. It's all built using CDK and .NET. I'll come back to that in a little while. So the second reason that Step Functions is my favorite AWS service is around the integrations. So historically, Step Functions integrated with around 17 AWS services. Things like Lambda, EventBridge, DynamoDB. As of last year, the Step Functions team released the SDK integrations. What that now means is that you can integrate with over 200 AWS services and over 10,000 different API calls directly from within your workflow. I'm yet to find an AWS service that I can't integrate with. So if anybody does, please come and let me know because I'd be interested to learn what that is. This opens up a whole range of possibilities for things you can do in your workflows without needing any glue code that's just making an API call. It's incredibly powerful. The final part of Step Functions I want to touch on is the Step Functions intrinsic functions. So Step Functions intrinsic functions allow you to perform different functions within your workflow. Things like checking the contents of an array, the length of an array, base 64 encoding and decoding strings, generating hashes, random numbers, unique identifiers. You can do all of this within your workflow without writing a single line of Lambda code that you might needed to use originally. In this architecture, we'll get to in a little while, but we use the states.uuid function that's up there to generate a unique identifier. So when we receive the requests into our API, we generate a unique identifier from within our workflow. So that's the first service. That's the first service that is really valuable to this architecture. The second is Amazon EventBridge. Now, Amazon EventBridge is Amazon's serverless event bus service, and it provides a really easy way to start to decouple your applications, decouple your producers from your consumers. EventBridge makes it really easy to connect your applications together. It allows you to ingest, filter, transform, and deliver events without writing any custom code. And because EventBridge is completely serverless, it scales as you start to use it more, and you only pay for the events that you ingest. So at the producer side now, so from a producer perspective, there's a range of different sources that EventBridge has. One of which being AWS services that you're already using today. If you launch an EC2 instance, that will publish an event to EventBus without you doing anything. If you launch a database, it will publish an event. That is happening right now in all of your AWS accounts without you configuring anything. The second source you can use for EventBridge is your custom applications. You can define custom events and publish them into EventBridge using the EventBridge APIs. And the final source for EventBridge are third-party SaaS providers, so companies like Salesforce, Datadog, Zendesk. They can publish events directly into the event bus in your AWS account. So that's the producer side. What about the consumer side? So consumers define rules on EventBridge, and then rules can have targets. Each rule can have up to 5 targets, and each bus can have up to 300 rules. These targets can be things like Lambda, things like SNS. You can make custom HTTP API calls from EventBridge. Most importantly for us, you can invoke a step function directly from EventBridge, and you can pass that event payload into your workflow as the input to your workflow. That is really powerful when you start to build these event-driven systems. You can now trigger your business workflows from events without writing a single line of code. A final feature of EventBridge that I just wanted to touch on is the schema registry. So if you enable schema discovery on your event bus, EventBridge will start to monitor the events that are flowing through your bus and actually generate you a registry of all the schemas that are flowing around. Now, if you think about that, if you're a developer now and you want to add a new feature to your system, you can now go to this single pane of glass, this single registry, to look at all the events that are flowing around your system right now, and just start to consume that stream of events. And you can do that without changing the existing applications, without changing any existing code. You can just hook into that event stream that is already flowing around. Okay, let's actually get into this architecture now. And I know I've talked a lot about event-driven systems and thinking asynchronously, but in a lot of systems at some point you're going to need some kind of synchronous point-to-point API. In our system, we need that to get the reviews into our system. We need an API. That might be a mobile app, a web client. There'll be something interfacing with this system. And to do that, we're going to use a concept called storage-first APIs. And what a storage-first API does is it's an API like any other. It's REST-based, but it doesn't perform any business logic. What your storage-first API will do is just to take the request and just store it. The first thing it will do is store the data that comes in. And then any actions that need to happen off the back of that can happen in a more event-driven, reactive way. This is also really powerful because if you need to maybe replay some production load, or if there's an issue downstream, you've got that original request stored in a way that's durable, and you can use that again if you need to. So how do we actually build that on AWS? Well, we're going to use a combination of API Gateway and Step Functions. And we're going to use a variation of Step Functions called Step Functions Express Workflows. So in Step Functions, there's 2 different types of workflows. There's standard workflows, which are more aligned to long-running processes, business processes. Express workflows are more for fast, snappy data ingestion type workloads. One of the other benefits of using express workflows is that express workflows integrate directly with API Gateway. What that means is that you can invoke a step function from an API call. And then whatever the final output of your step function is, that will be returned back to API Gateway and back to your caller. So what we're doing here is the API request comes in to API Gateway. We generate a unique identifier using that intrinsic function I talked about earlier. We store that data in DynamoDB, store that durably, and then we publish an event to say that there's been a new review received. What this gives us is a really consistent and predictable latency because we're not doing any complicated business logic, we're just storing things. And it gives us that ability to handle any failures downstream or to replay events because we've got the original request as it came in. How that looks if we do this in CDK, again, this is .NET code. If you're not familiar with .NET, one of the benefits of the CDK is that language to language, a lot of the constructs are exactly the same and the property names. So what we're doing here is we're creating a new state machine. You can see that new default state machine up at the top there. That is a construct within the CDK to create a new step function. And then whenever I talk about building step functions in CDK, I always try to build these reusable building blocks. So you can see we've got there a few lines that just say workflow step dot. So that is not CDK code, that's custom code that I've written. So the actual implementation of that in step functions is hidden behind that method. The benefit of doing things this way is that, one, it gives you a really legible piece of code. I can now look at that and, broadly speaking, work out what's going to happen. Well, I mean, I can because I wrote it, but you can we're generating a case ID, we're storing the data in DynamoDB, then next we're publishing an event, and next we're formatting the response. So now we've got these reusable building blocks that we can use again and again in different workflows that are also really quite easy to read and understand. One of the most powerful things about building this in CDK is that very bottom section there. So you can see where I'm defining a new step functions REST API right down at the bottom. That's a pre-built construct in the CDK that I can use to build a API that has a step functions workflow behind it. So in 4 lines of code there, I'm defining a workflow, an API that's going to trigger a workflow. All that mapping, all the integrations, all the complexity is handled for me. Okay, so the most important part of this architecture is these native service integrations. So how can we integrate with almost any AWS service using the CDK? And there's a couple of places we do that in these workflows. The first is in the sentiment analysis, when we're using services like comprehend and translate to actually detect what the language is, perform the translation, do the sentiment analysis. This is all happening directly from the workflow without any custom code. Now, if you were to build this before these native service integrations, each of them 3 green boxes would have needed to be a Lambda function. That's code that you would need to keep up to date, packages you would need to keep up to date, code that has the potential to break, because as we kind of showed at the start, all of us here have made a change to a production application that has broken it. The second side of that is from a cost efficiency perspective. If you think now we're reducing 3 Lambda function invokes for every single execution of this workflow, and albeit them Lambda functions may have been in the order of milliseconds, but over a high volume, this will have a material cost to how much this system costs to run. The other place we're using this is when we're sending emails, because of course the AWS simple email service is just an API. So when we need to send emails, one of these generic, undifferentiated things that almost all businesses need to do in some way, we don't now have any code that we need to manage, code that we need to operate. We can do this directly from our workflows without any custom code. So how would we do that in the CDK? So as well as some of the native service integrations that have pre-built objects in the CDK, things like DynamoDB put item, EventBridge put events, these are pre-built constructs in the CDK. If you're using the SDK integrations, you get this object called call AWS service. And the call AWS service object is quite simple in the properties it takes. It takes the name of the service that you want to call, the API action you want to call on that service, and then the parameters that that service needs. And these parameters are the same parameters you would use if you were using the SDK in whatever way you use the SDK currently. In this instance, we're calling detect sentiment on comprehend. One of the other really powerful things about this construct is you've got that IAM resources section. And that's where you can specify the ARN of an IAM of an AWS resource. Because we're using comprehend, that's just a star because comprehend doesn't have a specific resource. But what the CDK will do when I compile this code is it will actually generate the IAM policies needed based on the IAM resources I specify in there. So I don't even need to think about how I give my workflow permissions to do whatever AWS service calls I'm doing. That will all happen within the CDK. Like I said, I do normally have a couple of demos in this talk. In the interest of time, I'm not going to be able to, but if you do want to see any of this running in action, then please come and grab me in one of the breaks, and I can show you that on my laptop. Okay, so what can you do now if you've found any of this interesting? Well, the first thing I'd encourage you to do is go and check out the serverless workflows collection on the Serverless Land website. So if you're not familiar with Serverless Land, the Serverless Land website is a website managed by the developer advocacy team at AWS. And it contains, amongst other things, snippets of code, different patterns you can build with serverless technologies, and this workflows collection. And this gives you kind of an idea of the things you can build with step functions. There's some AWS contributed, some community contributed workflows that you can actually deploy straight into your AWS account from within the website. There's links there to launch the CloudFormation. The second thing I'd encourage you to start doing is thinking about your systems as these reusable building blocks, these reusable components that you can kind of stick together in this event-driven way. And when you consider these building blocks are now made up of almost any AWS service, you've got this really powerful toolkit to start building out your applications in a way that reduces that code that you need to manage and shifts some of this responsibility onto AWS. And of course, let's not forget about good old Lambda. I'm not proposing at all for 1 second that we get rid of Lambda. The title of this talk was a little bit tongue-in-cheek. What you can use Lambda for is to really focus on them pieces of code that are going to make a difference to your customers. I know when I started doing development, I wanted to be writing code that solves hard problems, solves complicated things, not just making API calls to AWS services. So use Lambda to focus on the really, really specific things that will add value to your customers. And for the other things, making API calls, shift some of that responsibility onto AWS. And my final piece of advice to close is imagine the possibilities. Go and play around with this stuff. When I built this system, I was purely trying to see the art of the possible. How far could you push these native service integrations? What could you actually build with them? So imagine how this could fit into your applications, into your systems, and go and play. Thank you very much. So we should have time for questions, hopefully, if anyone has any. Yeah, it's really hard to see up here. Just, have we got another mic? Sorry. Could I grab another mic? It's just down at the back there. I think there we are.
Thanks. When you're writing all of this infrastructure as code, what advice would you give for writing tests alongside it?
Writing what alongside it?
Tests.
Tests?
Yeah.
That's a really good question. So because with say .NET, for example, we can just create unit tests like we would create any kind of unit test. And when you actually run your unit tests, you can then assert things against the objects that are created. So if I've created a Step Functions API, I can then return that into my unit test and start to assert things against that object, because that is just an object in any programming language. When you start to build systems like this, I know typically people talk about the testing pyramid. You can actually start to think about it more as like a hexagon. So your unit tests become slightly less important, is that the right word? But your integration tests, testing how things talk to each other, become more important. So as well as having some unit tests on the actual constructs themselves, you may also write some integration tests against the workflow. So send a dummy payload into your actual step functions that are actually in AWS. and then check the response that comes back in that actual workflow. So there's two sides to that, really. Any other questions? Yes, I can probably hear.
Hey, thanks for the talk, very interesting. So you talk about simplifying things, making things less complex in the generic domain.
Yeah.
Thank you. So I feel there's a point where you touched on it before. You're shifting the complexity around a little bit.
Yeah.
One of the biggest problems I find for developers is dealing with IAM.
Mm-hmm.
How does CDK, how does what you propose make it easier for developers to deal with IAM, but while ensuring that their company, their business gets the relevant permissions they require? And how, sorry, it's a kind of double question, how does that bubble up so you can audit, you can show those IAM permissions, this policy?
So that's a really good question. When it comes to IAM with the CDK, if you look, I've just flicked back through my slides there, but if you look at that line there, most of the constructs in the CDK have methods that simplify how you add IAM. So you see there I've got a DynamoDB table, I'm granting read-write from my DynamoDB table to my workflow. So in terms of actually defining the IAM and understanding IAM as a developer, there's methods built into the CDK to kind of simplify that. So you don't need to know the individual IAM actions, because you're right, it's confusing. I get confused. I'm like, which DynamoDB permission do I need? So that's built into the CDK in a lot of cases. And then when it comes to step functions, like I said, if you're using the step functions constructs, when you synthesize the CDK code, that will automatically add the required IAM based on what you're using on there. Okay, awesome. I think if anyone has any more questions, if you want to just grab me afterwards, we need to go on to the next talk.